supply of people, it's not much range, whereas the second one is longer in range.
Yeah, you might say it's
more.
sort of three processes. There are a bunch of people to survive the first one, then they've got to survive the second one, and then they've got to survive the third one. And there may be three different stages of recovery, right? And there's a peak there of people who survive about that long. And then that may be the way that you produce as a net result across everybody, this kind of distribution. That might be a better way of summarizing. But the point is, in all of this, of course, is that we started with lots of data, all the people who've ever had this injury. And now we're trying to communicate to people what we know about that. How do we take this information and describe it in an accurate way? And the point is, we could do it very simply, but we might not do good justice to the data, and people might need more information than a mean or a simple variance or a skewness, or even the number of modes. In fact, we may have to provide all that information. In fact, in some cases, we may want to see the entire distribution. The people at FDA might want to say, well, I'd like to see the entire distribution of scores. Is it the case that we have kind of a nice normal distribution? About half the people are more fatigued, half the people are less fatigued. But there's a spike over here. There's one group of people who get very, very fatigued. What's that about? You might begin to say, well, maybe there's a subpopulation that reacts to this drug. You know, if you're drinking coffee and taking this drug, they interact with one another, such that you get high fatigue levels. That's what's producing this spike over here. And I wouldn't guess that if all you did was give me that mean value. I wouldn't guess that if you gave me the mean plus the variance. Both of those were informative, but it was not informative enough. Maybe you would need to show me the entire distribution so I can look for spikes or peaks or valleys and try to get some understanding. What if it looked like that? Some people are much less fatigued, but some are much more fatigued. Nobody is about the same. Nobody is unaffected by the drug. Now we've got to figure out what causes some to have the positive, less fatigue effect and others to have the negative, more fatigue effect. And maybe we can identify what differentiates these two modes and say these people it's safe to take the drug, these people it's not so safe to take the drug. Or expect the side effect if you have these properties, don't expect the side effect if you have that property. But you can begin to get some insight if you provide this extra information besides those simple summaries, the simple mean, for example. Yeah? Okay, now let's turn our attention to a discussion of proportions or percentages. We won't spend a lot of time on this, but I think we'll at least get some of the key problems that arise when people try to communicate information in these terms. As you all know, a percentage or a proportion is a ratio. It's a calculation of it's a way of comparing two numbers. A number with some base number. The base is the denominator of the ratio, the number that goes on the bottom of the ratio. So if I'd say what's the percentage of males in this class, I might take the total number of males and then divide it by a base number, which is the total number of students in the class. That will give me that proportion, multiplied by 100 to get a percentage. Or if I wanted to say how much of the federal budget in the UK is spent on paying off interest on money lent to the UK, I might take how many, well, if it's UK, I use pounds, but let's say dollars in the US example, how many dollars are paid out in interest every year versus all dollars, federal dollars spent for all purposes. And that would give me the percentage. Very familiar kind of notion. It's a way of making a relative statement about frequency. Now, where do problems arise with the use of such proportions or percentages? There are half a dozen, well, there are 3 or 4 at least that come up all the time. And the first of them is when the base, the thing that goes in the denominator, is a very small number. Let me illustrate this by saying, suppose I do a survey and I say 50% of those who I interviewed were in favor of raising taxes. 50% were against, 50% were in favor. Okay? And that's not so terribly odd. Maybe you know, the question is, are we going to have to close NHS hospitals if we don't raise taxes? And people say, well, if it comes down to keeping hospitals open or raising my taxes. Some will say, well, under those circumstances, I'd be willing to raise taxes. Others say, even under those circumstances, I'm not willing to raise taxes. My point is, would you put the same meaning to this proportion if you had 2 interviews or 200 interviews? What difference would it make in terms of interpretation of the percentage, the proportion, if the base, the thing that went in the bottom, was only 2 in one case versus more than that? Yeah.
It's not necessarily representative, it's just looking at 2 people's opinions.
Yeah, I mean, you have general suspicion of small samples to begin with, but in addition to that, you also realize that there's not much margin for error in the first case. You know, suppose there is some random error in my survey. People don't hear my question, or I don't hear their responses, and I misrecord their responses. So what that means is that very small changes would make huge differences in the first case when I have a small base, and would make much less difference in the case of having a larger base. So if suppose I only misrecorded one person as anti-tax increase, so one person that said that they were against it really were in favor of it. It was my mistake, some error of measurement going on. Well, that would change my percentage from 50% are in favor of a tax increase to 100% are in favor of a tax increase. Just that one error. But that same one error would have a very small difference impact on my percentage in the case of the 200 person survey. Right? So when you have very small bases, changes or errors have much bigger impact and will move the percentages around much more in the case of small samples. So if you have a very, very small sample, it's usually a lot more informative just to give people all the numbers than to use percentages at all. So don't tell me the percent that were for and against tax increase, but tell me how many people you interviewed, how many were in favor, and how many were against. And when I know your sample is based on only 2 people, I, for multiple reasons, am very cautious in using that statistic and thinking that I know how people feel. But the more common kinds of errors that arise with proportions or percentages arise when you compare or combine these things. So let me give you some examples here. So, combining percentages when the bases are different. Here's an example. Wages have gone up 5% and taxes have gone up 5%, so citizens have nothing to show for their raises. You will hear people make statements like that. But implicit in that comparison is that